Let's start with questions. Do you guys have questions from homeworks or whatnots? Ava?
I have a question for number 7 on the first one.
Sure.
I don't know what to ask.
Shut up, I don't know.
Numbers. All right, so let's start with, yes.
Can we do whatever worksheet would be awesome? Yeah.
So the quiz,
Can we do the homework? See, like, some examples.
yeah, that's what we're asking about right now. Well, the quiz will be on worksheets 1 and 2. Since I've already just loaded in the worksheet 1 stuff, can we start with questions from that before we move to worksheet 2? Just to keep everybody kind of a little bit more organized and on the same page before we start jumping back and forth between problem types. Is that okay? Okay. Delaney.
We do worksheet 1, 4 and 6, please.
Yes. All right. So for worksheet 1, I am going to be exclusively using my unit circle. So the first thing I'm going to do is I'm going to use the interval that it's given to figure out where on the unit circle I need to be looking. So I go to my unit circle. So from 0 to 2 pi is a positive number. So I'm going to be going counterclockwise. So starting at 0, I go all the way till I get to pi. So I'm going to be looking in quadrants 1 and 2 for my solution. So far, so good?
Yeah.
Ava?
How do you know you're going? Can you just say that?
So the interval is between 0 and pi. So if I start on my unit circle at 0, and because it's a positive angle, we're talking about 0 to pi, we're going counterclockwise.
Yeah, and I got it.
We're covering everything between 0 and pi, which is all the angles in quadrants 1 and quadrant 2. So far, so good? Look at the interval that's given.
Oh, I'm done.
That's okay.
So it's like pi.
So now I'm going to go and look at the equation that I'm given.
Yeah.
On the unit circle, tangent is y over x. So I'm going to rewrite the square root of 3 as a fraction. I'm going to call it the square root of 3 over 1, and I'm just going to put that negative sign out front. So far, so good? So what it kind of looks like is that I'm looking for the place where x is 1 and y is the square root of 3. Well, if I go and I look at my unit circle, there's no place where the x coordinate is 1 and the y coordinate is square root of 3. But I do see a place where the x coordinate's numerator is 1 and the denominator or the numerator for y is square root of 3. Do you see that?
Yeah.
So in that case, the denominator with them is 2. So what if I just take this and multiply it by like 1/2 over 1/2? So I could make square root of 3, a coordinate on my unit circle. I don't have any regular square roots of 3 on my unit circle, but I have a square root of 3 over 2. So if I multiply the top and bottom by 1/2, I can turn that square root of 3 into a coordinate that I do see on my unit circle. So what am I saying here? I'm looking for a place where x is equal to 1/2 and y equals square root of 3, but one of them has to be negative, right? Because that fraction is negative. So either the x has to be negative or the y has to be negative, but not both of them. Everybody's good with that? So I'm going to go to my unit circle in quadrants 1 and 2 and look for a place where I see x equals negative 1/2, y is positive root 2 over 2, or x being positive 1/2 and y is negative root 3 over 2. So let's look at that second piece first because, well, quadrant 1 is where x is positive. So I see x equals 1/2 there, but y is positive also, so that one doesn't work. So let's keep going into the next quadrant. Here, x is negative 1/2, y is positive root 3 over 2. That's what I need. So my answer should be 2 pi over 3 or something coterminal to that. The last thing I need to do now before I say that I'm finished is just to check to make sure that 2 pi over 3 is between 0 and pi. So I'm just going to look at the coefficients. So is 2/3 in between 0 and 1? Yes. So I'm good. Now, all these things that I wrote down, do I really need to write any of this down? No, there's really no work to be shown for these unit circle problems. If you can do it without writing anything down, you're welcome to do that. If you want to write stuff down because you can't hold it all in your head, it's okay to do that. The tangent ones are the ones where probably you want to write something down just to make sure you don't screw up what's x and what's y. Delaney, are you happy with what we did here?
Yeah.
Okay. Follow-ups on number 4. Questions still on number 4, because Delaney asked about 6 also. I want to make sure I get that before we take a second question. Reagan and, oh my God, Sydney, it has escaped me for a minute. Do you guys have separate number questions or follow-ups on this?
Just separate.
Okay, let me do 6 and I'll come back and hit you guys, okay? Don't forget what you wanted to ask. All right. So 6, it looks a little different than the previous ones because what don't I have? I don't have an interval, right, between two angles. But what I have is a sine or a y value, and I have a cosine or an x value. So all I'm going to do is go to my unit circle and find where x is 1/2 and y is negative root 3 over 2. Wait a minute. That's almost the same thing we did. So x positive 1 over 2, y negative. So we should be 5 pi over 3. And we're done. That's it. That's easier because it's not telling you where to look. It's telling you exactly where to look. It's like not be like, look over here when it kind of looks like this. It's saying, no, go right there. That x, that y, done. Okay. Reagan.
I was just going to ask you some of the sine.
Oh, okay, perfect. Are we ready to move on to worksheet 2 then? If there's still things you want to talk about worksheet 1, speak up. I'm happy to do more. But if you're ready to go to worksheet 2, let's go to worksheet 2 then. All right, let's see. All right. Where should we start? Number 1. Okie dokie. So to do these problems, I need to start by drawing a picture. So I'm going to draw myself like an XY axis. And I'm going to figure out where my answer needs to be by looking at the interval that's covered. So it needs to be between pi over 2 and 3 pi over 2. So I'm just going to start at 0. And because these are positive values, I'm going to be going which direction? Counterclockwise. So every quadrant is 90 degrees or pi over 2. So there's pi over 2 there. 2 pi over 2, or just pi. And then 3 pi over 2. So in between that should be that area right there. Quadrants 2 and 3.
Where did you get like the pi?
So each quadrant is 90 degrees. And 90 degrees is the same thing as pi over 2 radians. So each quadrant is pi over 2. So going from 0, and then I go 90 degrees, I've done 0 plus pi over 2. So that's pi over 2. And then going from pi over 2, if I go 90 degrees, that's pi over 2 plus pi over 2. So 1 pi. So I'm just adding pi over 2 each time. Is that...
How did you get the quadrants? Like, how'd you know it was those two?
Because it says it needs to be between pi over 2 and 3 pi over 2. Does that feel okay?
Yeah.
Okay. So now I'm going to try to figure out between quadrants 2 and 3, which one is really the one that I need to be looking at. So this is the same thing as saying sine theta equals 0.11, right? Which is basically saying where sine theta is positive. Now remember, we made an acronym to help us remember which quadrants the trig functions were positive in, right? Do you remember what the acronym was? 0.11 is positive. It's just whatever the number is. Like if it's a negative number, then sign would be negative, right? That's it. Is that okay? Who remembers the acronym? All silly turtles crawl. That's what they told me when I was in your age and doing the same thing. That should be easy to remember, right? Okay, what do the letters A, S, T, C really stand for? A stands for all, because all 3, sine, cosine, and tangent, are positive in the first quadrant. S stands for
Negative
sine. So sine is positive in the second quadrant, but cosine and tangent then would be negative. Tangent is positive, sine and cosine negative, very good. And then the C means cosine positive, so sine and tangent would be negative. So the 2 places where sine is positive is in quadrant 1 and quadrant 2.
Why do you have more than one? I can't.
Well, remember sine is y, right?
Yeah.
So where on the xy axis is y a positive value, a y coordinate positive? Quadrant 1 and quadrant 2, right?
So you're always gonna have quadrant.
If you're talking about something that's positive, yes.
So you always want to quadrant
if it's a positive value, yes, but if you go down and do like 3 where it's a negative,
If it was negative, you're fine.
correct, you would include quadrants 3 and 4. Does that make sense?
Yeah.
So like the upper part is positive.
For y,
Yeah.
correct. And just like if you're talking about x, the right side is positive and the left side is negative, right? Okay, so where is our answer at? What quadrant does this have to be in? Quadrant 2. That's the only place where both sign is positive and your angle is between pi over 2 and pi over 3. I'm sorry, 3 pi over 2. So I'm going to draw a standard position angle now. So initial side on the positive x-axis, terminal side in quadrant 2. That's where my angle theta is.
Yeah.
Does it matter where in quadrant 2 I put that terminal side? Not really. Just put it in there somewhere. I usually stick it in the middle so there's plenty of room to write around it. Scale doesn't matter. Okay. Now I'm going to draw in the angle that we've called alpha. When we draw our alpha, we always put it between the terminal side of theta and the part of the x-axis closest to the terminal side. So it would go there. That's alpha. It's like the Jesus fish. Everybody okay? Our picture is now complete. What we're going to use this picture for is to write an equation that relates theta, alpha, and the piece of the x-axis that forms the other arm of alpha. In this case, that's pi. So if I look at that picture, does theta stop before pi or after pi? Before pi. How much further would we have to go on theta to get to pi? Alpha more. Everybody agree? Because alpha is what's in between the terminal side of theta and pi on the x-axis. So if I want to solve this equation for theta, I just subtract alpha from both sides. And now this is what I'm going to type into my calculator. Now, remind me again, how do I type alpha in? It's always going to be, in this case, sine, because we're doing or sine inverse, because we're doing a sine problem. Absolute value, and then whatever sine or cosine or whatever was equal to. Now, when I type this into my calculator, I am never going to type in the absolute value because, like, shoot, Mr. Kulik, I'm pretty confident I can do the absolute value of a number in my head. I don't need my calculator to do that for me. Right? What's the absolute value of 0.11? 0.11. So I'm just going to do pi minus sine inverse 0.11. And then press enter. What mode should my calculator be in right now? Radians. So if you got a number in like the 300s, you're in degree mode. So just change your mode to radians. We've talked about how to do that. If you need help, ask a friend or ask Mr. Kulik, and he will happily make sure your calculator gets into radian mode.
How do you change it to radian?
So you see the blue button? The button next to it says mode. Press that. And one of the options should say degree or radian. Make sure the radian is highlighted by pressing enter to highlight it. And then you exit back out and you just redo it and you should be good. Okay, can we check this?
Yes.
All of our answers on sheet 2 are checkable. There's no reason when you finish a question you should not know whether it's right or wrong. Let's show you how to check it. So first thing I want to do is sine of theta should equal 0.11. So if I do sine of that answer that I just got, I should get 0.11. Yes. The other piece that it has to do, the other condition it has to meet is that that 303 has to be between pi over 2 and 3 pi over 2. So 303 definitely bigger than pi over 2.
Wait, so I could just like give the answer, like, just put it up.
And definitely smaller than 3 pi over 2. I don't know how you're going to get the correct answer without drawing the picture. Because getting this equation came from the picture. That's the point of drawing the picture, is so that we can correctly write this equation every time. Reese.
Can we do number 3?
Absolutely.
You're right.
So the answer was that 303 that we got on our calculator. Right, when I typed in pi minus sine inverse of absolute value 0.11 and I get 303.
So why did we have to go with graph things?
That's
You
what I was
just give pi
thinking.
minus sine 0.18 and that's
To get this equation, I needed to the picture. That equation is going to be different for each problem potentially. And the only way the best way to ensure that you write the correct equation to solve for theta is to draw the picture. Okay? All right, let's do number 3. So, again, we're going to start by figuring out what quadrants the interval covers. You could just sit in front of her. There's like 6 desks in front of Sydney. You could just sit at the very front of the room.
Sit at that top.
the seat's nice and warm, right?
Doesn't look like I had to.
Everybody okay with that part right there?
To my left. Let's do it. So it would be quadrant 3.
So tan theta needs to be negative, right?
Yeah. Oh, wait, no. Sorry. It'd be quadrant 2.
Correct. So the two places where tangent is negative is in
Isn't it one
Sine and cosine. Yeah, it's 2.
Yeah, it's 2 and 3, right?
It's just 2.
Yeah.
It's tan's positive.
tangent is negative in quadrants 2 and 4.
It is. Would you use the graph?
What was that, Pauline?
What was like the blue for?
That's where tangent is negative, which would have been quadrants 2 and quadrants 4.
What the first grade thing?
Is it always gonna be like that? I got you.
So, shh.
Yeah.
So if we look,
Here.
hold on one second. I'll get to each one of your questions. I see you. Let me get it. We're like right here at the end, right? I've drawn in my theta. What do you notice about this picture and the previous picture?
They're pretty similar.
They are not just pretty similar, they are the same picture, right? My theta, alpha, and part of the x-axis are all identical. Everybody agree? So this one works out to be exactly the same equation, except alpha this time is tan inverse of the absolute value of negative 5.25.
Okay.
Because the problem was a different problem, so that the alpha is a different number. So 1.75 or 76, I guess. Reagan, you had a question? I'll get to you too, Ava. I see you.
Why is it how do you know it's the fourth?
So remember the letters ASTC are acronyms telling us which quadrant sine, cosine, or tangent is positive in. So A in quadrant 1 means all three, sine, cosine, and tangent, are positive. S in quadrant 2 means sine is positive in quadrant 2, but then cosine and tangent are negative. So that's why quadrant 2, because tangent negative there. The T in quadrant 3 means tangent is positive, but then sine and cosine are negative. So not quadrant 3, because we want where tangent is negative. And the C in quadrant 4 is cosine is positive, which then means sine and tangent are negative. So that's the other place where tangent could be negative. Does that feel okay, Reagan? Okay. Ava, I see you too, Nora. I'll get to you in 1 second.
I was confused on where we draw the line on the graph.
Yeah.
So, like, how do we know it's gonna be like? Is it just anywhere in the?
Anywhere in quadrant 2 is fine.
Okay. Okay.
It just needs to be in quadrant 2. Yes, Nora, go ahead. So,
Great.
I definitely know the answer to that one.
Can we do number 2 just like super quick?
Let's do actually a different one because 2 is the exact same picture again.
If we do one of those,
Let's do 5.
Five.
Yeah. Okay, this will be the last one, and then it's got to be time to start, okay?
Ready for it? Oh, so we gotta move all that?
So we're going to start by figuring out what two quadrants are covered from 11 pi to 12 pi.
So it'd just be quadrant 1 and 2.
Well, yes, but I'm going to count around. Three and a half, 4, 4 and a half,
So you can just show us.
5, 5 and a half.
You can skip. You can skip.
Is this one gonna be on the quiz?
Hey, just let's do the problem. I picked it because I thought it was a good representative one. Okay? No, none of these problems are going to be the exact problem on the quiz.
So like one where it looks like that one.
This is, okay. All we're doing is counting right now, though, right? We're just counting by halves.
Going around. We're just going around. It starts
So we're at 5 and a half. Now we're at 6, 6 and a half, 7, 7 and a half, 8, 8 and a half, 9, 9.5, 10, 10.5, 11. Oh, good. 11.5, 12. Yes, Ava.
So we're just adding 2 pi until we get into the range of 11 pi.
I was just counting by half pies. Each quadrant is 90 degrees. That is pi over 2. So I just counted by a half. So 0 to a half. A half more is 1. 1.5. 2. 2.5. 3. 3.5. And I just kept going around until I got to 11 to 12. Just counting by halves. We can count by halves, right?
Yeah.
Okay, if you want to write them as decimals, write them as decimals. You don't have to write it as a fraction. It's fine. So far, so good?
So we always want the top to be pi over 2.
That's just how 90 degrees per quadrant works, right? Unless you're using negatives, but our angles here are positive, right? So here we have cosine theta is 0.19, or cosine is just positive. Where is cosine positive? In quadrants. Cosine is positive. What 2 quadrants? Excellent. 1 and 4 for all and for C. Everybody's okay here? Okay. So I'm going to draw my angle now. There's my terminal side. Now to draw theta, how many times around am I going to have to go before I run into my terminal side? I went 1, 2, 3, 4, 5 times around. So 1, 2, 3, 4, 5. Oops. I messed up. 1, 2, 3, 4, 5, and there we are. Woo!
Jeez.
This is something we did in chapter 2 already, right? Where we drew these standard position angles, right? I'm going to draw in my alpha now. That goes between the terminal side and the x-axis closest to the terminal side. And now I'm ready to write my equation that relates theta, alpha, and the part of the x-axis closest to the terminal side of theta. So I'm going to ask you, does theta happen before or after 12 pi? Before. Okay, how much would we have to add to theta to get to 12 pi? Alpha. A lot. So I subtract alpha from both sides, and now it's calculator time. What is the alpha in our case? Cosine inverse of 0.19. So I get 36.2 or thereabouts. How do we check that again? We do cosine of our answer to see if we get 0.19. Yes. And then we check to make sure 36.2 is bigger than 11 pi. Yup. And smaller than 12 pi. Yup. Answer done. Ava.
I still don't get the, when we did the graph, it was 0 to 5.5.
I need to have this label correct because that was part of the equation that I wrote. So that was just me counting around to get the label correct. Well, we didn't do tan, we're doing cosine.
Yeah.
All, well, S says sine is positive in 2. So cosine and tangent are negative. What's cosine supposed to be in this problem? Positive, right?
Yeah.
Is that, you tell her, Mary. Reagan, did you have a hand also? Oh, Ellie.
I was just wondering if I could.
Oh, yeah, certainly. All right.
Oh.
You guys ready?
No. I think.
Readier than you were at the start of class?
Yeah.
Readier than we were at the start of class?
Yeah.
How many questions are on this?
There are 4.
Because we just asked it. And you actually touched it. It's a what? Okay.
There's one on here, so you don't need anything other than your calculator. How many questions?
Oh, wait, I did this. Did I use it?
I have one on there.
Can I use it?
There's 4, that's all right. You don't need that. Yeah, she can use it.
Figure it doesn't talk about it. Yeah, like, I thought we did it. We were Stop. Exactly.
They've all spoken for. Oh, maybe there's one on my desk still. If there is, you're welcome to use it. No, you. Whenever she comes back. Shouldn't be any talking. If you have questions, you can come ask me.